Good day, everyone. So today we'll be treating functions, and here we have a question. It says soit f la fonction réelle d'une variable prière définie par f de x égale à x au cube moins 1. Right, we have a real function, and then it's defined by this. It's defined by f of x equal to 3 x raised to the power of 3 minus 1, and we're asked to prove that there exists a big M greater than 0. So what are we looking for? We're looking for M such that when you see tel que, it means such that, okay, such that for every x in real numbers, x minus 2 in absolute value less than 1, strictly less than 1, implique that f of x minus 7 is less than this M we are looking for. So our answer should be in the form of this, then the M we are going to find, and then x minus 2. Okay, so what do we have? We say montrer en utilisant la définition, that's the second part of the question, that the limit of f of x is equal to 7 when x tend vers 2. So we're going to start with our solution. First, what are we going to do? We're going to first work with this, because the thing is, if we have this, then it implies this. Remember, and this is what we are looking for. So we have to expand this in absolute value, and we know what our f of x is. It is x raised to the power of 3 minus 1. Okay, so we begin. Now we have f of x minus 7 is equal to x raised to the power of 3 minus 1 minus 7, which is equal to x raised to the power of 3 minus 1 minus 7 will give us minus 8. And this also can be, like, we can expand this. How do we do that? I know that, remember, we have this, and if I want to expand this, I know that I can have, like, for those that are really good at expanding, then for those that are not like really good at that, we're going to work something out. We are going to divide. So I know the first thing I'm supposed to have here will be x minus 2. So how am I going to get the second part? I can get the second part by dividing what we already have. So what do we have? This is for those that are not good at it. If you're good at, what you're supposed to get, you can skip this part. So I have x raised to the power of 3, 8, and then x minus 2. So what am I going to have? X raised to the power of 3 in x, like x in this, in x raised to the power of 3. I have x raised to the power of 2. That is like me saying x raised to the power of 3 over x. This cancels, I'm left with 2. This x raised to the power of 2. So that's this x raised to the power of 2 here. So x raised to the power of 2 times x is x raised to the power of 3. Then x raised to the power of 2 times minus 2. This will give me minus 2x raised to the power of 2. And x raised to the power of 3 minus x raised to the power of 3 is 0. Then this is minus, which will become plus. So plus 2x raised to the power of 2. Now plus 2x raised to the power of 2 going x, that is 2x raised to the power of 2 over 2. This 2x raised to the power of 2 over x. This will cancel, so I'm left with 2x. So this will be, here will be plus 2x. Okay, so it will be 2x times x, which will be giving me 2x raised to the power of 2, and 2x times minus 2. This 2x times minus 2. I don't know if you see what I'm doing here. So this will give me minus 4x. Okay, then I subtract as always. Okay, so 2x raised to the power of 2 minus 2x raised to the power of 2 will give me 0. Then minus will give me plus, so I have plus 4x. I apply the same thing. I have 4x going x, it will give me 4. That's me having 4x over 4. This will cancel, so I'm left with x. 4x go, I'm left with, that is 4x over x, I'm sorry. So this will cancel, I'm left with 4. So here I'll be having a positive 4. Okay, so a positive 4 times x will give me 4x. and then a 4 times minus 2 will give me minus 8. Remember at the beginning we had our minus 8, so I have minus 8, and then I subtract. This will give me 0. So minus 8 minus minus will give you plus. So it's like you say minus 8 plus 8, which will also give you 0. So what do we have? We're having at the end that x3 minus 8 is equal to x minus 2, x raised to the power of 2 plus 2x plus 4. If you solve this, that is x raised to the power of x minus 2 times x raised to the power of 2x. Like when you solve this, you'll be able to get, you get x raised to the power of 3 minus 8. We're going to replace what we've gotten here. So we'll have here x raised to the power of 2 plus 2x plus 4. Now, having this, we know that there's this rule that states that the product of absolute value is equal to the absolute value of the product. I repeat that the product of absolute value is equal to the absolute value of the product. So this is the product of the absolute value, like it's this, and then there's a product in between. This is multiplication. So this is now me saying x minus 2, because if I have to apply the rule, then the product of the absolute value is equal to the absolute value of the product. So this is x minus 2 then times what we have here, x squared plus 2x plus 4. Then this, now we have x minus 2. Okay, this works. It's fine. It's okay. But how about this? I can still break it down again, okay? And we know that, I'll do it here. We know that x squared plus 2x plus 1 is equal to x plus 1 squared. Let's confirm it. I have x plus 1 and I have x plus 1. So x times x is x raised to the power of 2 plus x, this is x, plus 1 times x is plus x, and 1 times 1 is 1. So I'm having x raised to the power of 2 plus 2x plus 1, which is this. So I have this x raised to the power of 2 plus 2x plus 1 is equal to x plus 1 raised to the power of 2. So I can have this, because I'm trying to have this. So what is left if I add 3, right? If I add 3 to this, I will come back and get this. Because if I have this, then I add 3. So it's the same thing as me saying x plus 1 raised to the power of 2 plus 3. You see it? That's exactly what we're going to replace here. So we're going to have x plus 1 raised to the power of 2 plus 3. Now with this, we've expanded it to get to this point. Now the next thing to do is bring in this first part, this and click this. So now we're going to work with this. What are we going to have? We're going to have x minus 2 less than 1 is equivalent to, if you have a value, an absolute value, if you have an absolute value, I should do that here. If you have an absolute value, let's say a less than 1, it is equivalent to you saying a is between 1, okay, and negative 1. So we apply the same rule here. Always remember that you can put that in your jotter. So I have this. So this will be the same thing as me saying x minus 2 is less than 1 less than negative 1. And so I can add 2 to both sides so that I will have only my x. So I will add 2 here. I will add 2 here and add 2 here. So of course this will cancel. And I'll be left with x is less than 1 plus 2 is 3. Minus 1 plus 2 is the same thing as saying 2 minus 1. So this will give you 1. So this here will be 1. Now I've also treated this case, if you notice. I've also treated x minus 2. So what is left is this. So what will I do? I will now add this one here. So it will become x plus 1. X plus 1, sorry. So at this point, I will add 1 here, add 1 here, and add 1 here. So what will I have? I will have x plus 1 est compris entre 4 et 2. You see? And just like the same thing, because we're trying to get this formula again. So what I'll do is I'll bracket it and raise it to the power of 2. So this raised to the power of 2. This what I do here, have to do it to the two other sides. So I raise to the power of 2, raise to the power of 2 here, and the same thing here. So if I do that, what am I going to get? I'll have x plus 1 raised to the power of 2 is less than 4 raised to the power of 2. 4 square is 16. 2 raised to the power of 2 will give me 4. Okay, so what is left? The thing that is left is for me to add 3. That's plus 3, which of course I'm going to do. So here I'm going to add plus 3, and then plus 3. If I do that, I'll be having x plus 1 raised to the power of 2 plus 3 is less than 19, because 16 plus 3 will give me 19, and then 4 plus 3, which will give me 7. So if you can see, this is majoré, like from what we've been doing. This is majoré par 19. So this will be our M. You can go back and check our video on how we define majoré. There it's clear, but for now, if you're just joining, we can say this is majoré par 19. Okay, so in the next video, which will be the part 2, I'll be doing the other parts, and then, but before we go, we'll conclude this particular question by saying, now we've gotten our M is 19. So tout simplement, on va juste écrire que petit x appartient à R, ok, x moins 2 inférieur à 1 implique que f de x moins 7, sorry, you can see that, f de x moins 7 est inférieur à, instead of putting the M again here, I replace it with what? 19, which is what we got here. So 19 x minus 2. That is what's the first part, which says montrer qu'il existe m plus grand que 0 tel que ça. That's what we are asked to prove, which we've already done. So see you in the next video, where we'll be treating the second part of the question, where we're asked to prove using the definition that limit of f of x is equal to 7 when x tend vers 2. Thank you very much.